Hmm. Good afternoon, economists. Today I'm going to do a little overview of Stata. Hopefully, a lot of this is a review. Probably some of it might not be, but that's okay. We're going to look at how to do some regression stuff in Stata, a little reminder of how to do it and where to find your stuff, where to put stuff, and how to get some of the basics of Stata knocked out. So, first of all, this is my version of Stata. It's a little bit older because I got it a long time ago. You can always do your updates as Stata opens. It'll ask you if you want to do an update. You can always click on that if you want to. There are a couple of different types of files with Stata, right? Remember, there's the log file, the do file, the data files, and those all have different pros and cons and different purposes. So for my purposes, I'm going to open up a do file that I started for today. And that is going to be the do file is a great place to store your commands that you want to run through and any notes you want to have. So I'm going to open this do file I've had before, and you'll know a do file because if you go in and look at, let's see in here, if you go and look at the different types of files that are made for Stata, the do files end in the letter do. Oops. Let's see, where's another do file? So there's a do file. And so it's got the file type is do, and that's why we call it a do file. But it also tells Stata what to do. The next file type is a log file. And logs don't do anything but track. They are great forms of tracking what you've done. So if I go here and click on a log file, you can begin or close or suspend a log file or append a log file. There's not a lot else you can do besides look at them, but they're great for keeping track of your results for a given day. So I might call my log file 145, 10, what's today, the 28th, or 1029. 2020, and here's the file format. You can put it in a Stata log document. And those can also be opened in PDFs and printed out, which is kind of useful. The next type of file is a data file, and so you can save your data set as a Stata data file, but you can also import your data in any format you want. And so if you go down and here to import, you can import an Excel spreadsheet, a CVS file, which is just a comma-separated variable file, or any of these other types of files. For my purposes, I've already got the example files I want to use, so I'm going to go ahead and take this line of code and use it to import the data set I want. And you can see, just like I would here if I went through and manually said import this Excel sheet and then selected it, and I'd select import first row as variable names, I could do that. But what I'm going to do instead is just go ahead and use this text, this command text that says the exact same thing, right? So it says import an Excel file from this directory, this file name, and then it says the sheet is called hprice, and the first row is variable names. So I go ahead and now I've got my variables are right here. I've also got my review of all the commands I've done before, and so if I ever want to go in and reuse a command, I can just click on it there, and that's pretty great. We can also go into the data editor and see all of our data. Sometimes, depending on how the data is constructed, you might have some additional stuff about the variable built in there, which can be useful. You can always add stuff in if you want to increase the formatting and the information associated with your data, but you don't need to. So for some simple basic commands, you might want to summarize your data. You can also just use the shorthand command sum, and maybe I only want to summarize a few really important data points like driveway, air conditioning, and garage. So I can choose to just summarize a few of them. And then if I want to do a simple multiple regression model, that would just be reg, and then my y variable, and then whatever x variables I think are important for my model. and go from there. That gives me my results table, right? I've got my number of observations, my f-stat, the probability that my f-stat is sufficiently high. Since that's very low, that's good. My r-squared, which tells me how much variation in y my model explains. My model sum of squares, my residual sum of squares, and my total sum of squares, my degrees of freedom here, which is based on my observations. The number of observations I have minus n plus 1, or it's n minus the number of x's plus 1. And so I've got 5 model degrees of freedom and 540 degrees of freedom from my total observations. I've also got my coefficients here. Remember, interpreting coefficients, a coefficient for a regular variable that has some quantitative value is going to be a marginal change in x has a beta hat sized effect on y. So in this case, each additional square footage of lot size is going to tend to increase house sale price by $4.79. My standard error, which you compare to the coefficient, you want your standard error to be less than half the size of the coefficient. You can also use the p-value to determine if your t-stat is sufficient that you can accept your coefficient. Regressions are automatically given with a 95% confidence interval, which you can also use to test the significance of your variables. And here I've got my variable gas is not significant at the 95% level. So what I can do is run it at a different level. So I can say, now I'm running it at the 90% confidence interval, and now gas is significant. I'm a little bit less certain about the validity of my variables, but I've got more, I've got them all significant. So that's some options you can do. You can also increase your significance level. Let's say we want to go to the 99% confidence interval, and let's just take gas out of there. And that's another iteration of our model. And we see all our variables are significant. We can interpret our coefficients. I also have some binary or some dummy variables in here. So lot size is the number of square feet. Bedrooms is the number of bedrooms. Bathrooms is the number of bathrooms. Garage is a binary, a dummy variable. So I would interpret that by saying having a garage tends to increase house sale price by $5,333.39, right? So that is a simple regression. The other thing you're going to want to remember to do is you might want to use outreg. And outreg is a great tool for pulling your results out of your Excel or out of your Stata. To use outreg, you might have to install it. So the command for installing the outreg package is ssc install outreg2. And you can just put it in there, and if you've already got it installed, it'll tell you that. If you haven't got it installed, it will install it. It's pretty straightforward. I've already installed it, obviously. And then I can use the command outreg2 to get my results. So outreg2 using, and then here you want to just name the file. And what it's going to do is it's going to create a file with your results table in it with the name that you give it. And so I can call it example results.doc, and it's already here. Here it says what directory I'm in. So I'm in my computer, my desktop, the teaching file, the Econ 145 file. If you haven't set a directory, you can do that up here by going to File and change Working Directory. And that just tells Stata, hey, this is where all my stuff is. This is where I want you to put all my stuff, right? That's the directory I'm working from. So if I go in and I say, outreg using example results.doc, append ctitle to say model 1, and it will go ahead and do that. And now if you have a PC, you can click on example results, and it'll open that file. If you have a Mac, you have to go to the directory, and it will say, hey, here it is. And now I go in and I see I've got example results doc, and I go ahead and open that example results doc. And here's my results. So here's my first model. Here is my coefficient for lot size. It's significant at the 99% level. There's my standard error term for that coefficient. My estimated coefficient for bedroom, for bathroom, and for garage. My constant, my number of observations, and my R-squared. And really, this is all you need in terms of results for your regressions. This is what you want to be inserting into your paper, right? So far, so good. There are also a lot of graphs you can pull out of Excel or out of Stata. Stata doesn't always have the prettiest graphs, but they can be really functional. So you can do a histogram. The command for histogram is just histogram and then variable name. So I'll do a histogram of sale price. And it should pop up for me. There we go. So I'm looking at the sale price of all of the houses, and you can see that a lot of them are consolidated over here at this 50,000 price range. I can also do a scatter plot of two variables. So let's do scatter, and then you have to have two variables. So I'm going to say I want to scatter sale price across lot size and see what that gives me. So now I've got sale price and lot size, and I can see there's a positive, generally positive relationship here. So that's cool. And there's a lot of other graphs you can do too. And so I'll put some more of those commands up together for you guys. You can also edit your graphs in here. So you can do things like change the color, add variable labels, change the axes, add a caption, that kind of thing. You can save these files separately and then paste them into your results. You can also go over here and actually generate a graph. Where is it? Here, you can select a graph that you want to do, and that'll also give you some options. So there's a lot of options there in terms of the graphs you might want to do. I think scatter plot and histogram's pretty popular. Not a lot of people want to do a box plot. What else? So now we want to, real quick, you can also generate a new variable. I think we talked about that a little bit in class, but let's say I want to generate, maybe I want to scale sale price down. So I want to scale it up. Maybe I want to generate a new variable. I'm going to call it sale squared, and it's going to be equal to, let's say, sale price. And then I can use the caret, oops, right? 2, and that's raising it to the 2-second power. So now I have this variable sale price squared. You could also do something like gen random, and I'm going to say random is equal to number of stories times 2, right? Or something like that. So you can do any kind of mathematical function you want in there. You can also, when you do a regression, you can predict the variables for your estimated Y variables. You can predict your residuals. You can graph your residuals. Those are all things you can do if you want to. I don't know if they'd have a lot of applications for us, but those are other things you can go ahead and do. And you can always check in here so you can see I, generated these new variables, right? So this one is sale price squared. This one is something random based on the number of, basically just taking the number of stories and multiplying it by 2. So all those are generated in there. The next thing I wanted to talk about is how to do panel data. So I'm going to go ahead and clear out the data I have. Stata will not let you put new data in if your data is, if you already have a data set in there. And then I'm going to go ahead and import this new data set that is a panel data set. Oh, wrong one. Gosh darn it. There we go. And anytime you want to make a note in your log or in your do file, you can always write notes in Stata without getting an error message. Oh. if you use 2 asterisks, like that. Or 1 actually. And that way you can, give yourself, so like here you can see I've given myself notes. So now I've imported a set of cross-sectional, or of panel data, so not cross-sectional. So I've got countries, I've got years, I've got some Y variable and 3 X variables. And so I can go ahead, and the first thing I want to do, all the commands for using not cross-sectional and not time series panel data is going to require you to use that XT first. And that's kind of saying like, hey, this is panel data because there are lots of categories over time. And so the first thing we want to do is tell Excel XT set what my observation, right? My category variable is. In this case, it's going to be country, and what my time variable is, which in this case is going to be year. And so I get that. It says your panel variable is country, your time variable is year. Strongly balanced just means there aren't any missing observations, which is great. If you do have missing observations, you'll get back unbalanced. And if you have questions, we can talk more about the different types of panel data sets. If you don't have your countries coded already to letters or numbers, you can also use this set of code here, where you say encode country and then gen country 1. So then I would say like encode whatever my variable is if it's not categorized. So if I've got state names in there, you can say encode state, and then I would just say to go ahead and generate, and then a new variable name. So coded state or something like that. And you want to be careful because it's going to come as an error because there's no variable there. Anything you do in Stata, it's going to be case sensitive. And so you want to keep that in mind. It's going to care if you use an uppercase or a lowercase. So for example, if I wanted to say summarize country and year, I'm going to get an error message because there's no variable year with a capital Y. There's only a variable Y with a lowercase y. So now that I've told Stata what my panel variable and my time variable are, and the change in between the years is 1 unit, I can go ahead and do line graphs with them. So we can do an XT line graph with, let's say, my Y variable, and see what that looks like. And that will give me a series of graphs. We talked about that a little bit last time. I can also do it layered with the overlay, and that puts them all in one big graph. So that'll be really interesting for a lot of people who have either panel data or time series data. And again, you can always go in and edit those too. And then the next thing we want to do is we want to do a fixed effects or a random effects model. And the difference between the two is whether or not you think that there are some unexplained variations between your categories that is correlated with your Y. So I think I took it down here. So if you're thinking about your panel data and you've got Y, TI, and you've got your beta 1, X, TI, and then there's some error term, TI. If there's also some constant, some variable that doesn't change over time, but is different between your areas of observation, between your categories, I'm going to call it alpha I, so it doesn't change over time, but it is going to be correlated with the cities, then you want to use a fixed effects model. If your model is more like this, where it changes over time and from city to city, then you can use a random effects model. And I think most people in our class are going to be needing to do a fixed effects model. But you can also test it with the Houseman test. You can also look at the row, which is I'll show you, it's in your results. So let's do xtreg, xtreg, and then I want to pick my y variable and my 3x variables. That would bother me, so I'm going to go ahead and fix it. There we go. And if you just leave it like that, you'll get a random effects. So here we've got group variables, country, number of observations, number of groups, 7 countries, observations per group, 10. The average is 10, the minimum is 10, the maximum is 10. I've got the R squared within each country, between countries, and overall. I've got my coefficients to interpret here. And so basically what you want to do is you want to interpret your coefficients for your panel data as saying, for a given I, as X varies across time by 1 unit, Y changes by beta units. So as countries, as a country's GDP varies over time, or as a country's, let's say, unemployment, maybe X1 is unemployment, as a country's unemployment rate varies over time, we're going to see it tend to change GDP by 1.73 or something like that. Does that kind of make sense? Hopefully. You want the standard errors to be small relative to your coefficients. You want your p-values to be very small. In this case, we don't really have a lot of, I don't really have any significant coefficients, which isn't great. And then we can go down here and look at rho, and rho is the fraction of variance due to UI. And basically what that's saying is it's the interclass correlation of the error. So as rho approaches 1, the individual effects of whatever your observation class is are going to dominate the idiosyncratic error, which just means there's not a lot of, it's asking how much of the variance comes from your error term and how much comes from this other possible correlation, this error term that's city specific or state specific or country specific. So you want your rho to be low for a fixed effects model. So let's try a fixed effects model. That's just going to be xtreg, and then my variables y, x1, x2, x3, and then just comma fe for fixed effects. Woo! So simple. Everything basically stays the same. I see a little bit higher level of significance for my variables. My rho's gotten a little higher. The f-stat is still nice and high, and the probability that my f-stat is sufficient is nice and low. And I can still interpret my coefficients as the marginal effect of x on y over time. So far, so good. We can also do outreg, and here there's some more fun things you can do. There's actually a lot you can do with outreg in terms of making it give you really nice tables. So here, again, I've got outreg using, and now I'm called the document my results. I've asked it to replace the title and call it fixed effects, and then add the text country FE, comma, yes. And so when I open that, what you'll see is, where's my results doc? Now this model, there's my results, and it says my first model is my fixed effects model. I've got, and then it adds this line here at the bottom, country fixed effects. Yes. And that's cool, right? Because that's what I want people to know. This first model is a fixed effects model looking at country fixed effects. And that's what I told it to say. If I do the random effects model, so let's do that back up here again. And then I can do outreg and replace title, and I'll call it random effects, and I'm going to make it say no fixed effects. And now if I go and open that file again, well, fudge, that didn't work. Let me try one more time. Maybe? Oh yeah, so there's the new model. Cool. And then I can go and take that and paste it somewhere. So now country fixed effects, no, random effects model. That's cool. All right. The last thing we can do is we can run a Houseman test to determine if it's a fixed effects or random effects model is appropriate. And that's going to be based on whether the errors are unique or uncorrelated, right? Are the errors in the model correlated with your category variable or not? So you can we'll just do xtreg, and I'll do y and x1. And then what I want to do is estimate. This is going to estimate So we're going to use this estimates command, and then we're going to ask it to store the results as fixed. And then we'll use the same command to do the random effects model, right? xtreg, and then y and x1. And now we can you can say random effects, but it's going to automatically default to random effects. And then again, ask it to store the estimates as random. And that's just telling Stata to hold on to this information so you can call it back later. And what that means is that now when we go in and we put in the command Houseman fixed random, it's going to say, oh, you mean that stuff, those estimates that we stored as random and fixed, you want me to do a Houseman test on them? Cool, I can do that. And so there we get the Houseman test. And so here the Houseman test looks at the difference between the fixed effects model and the random effects model, and gives us a sense of whether or not the fixed effects or the random effects model is appropriate. And so basically what the Houseman test does is it's testing the null hypothesis, and the null hypothesis is that the random effects model is appropriate. The alternative hypothesis is that the Houseman test is appropriate. And so if your probability that your chi-square, if your p-value for your chi-squared here is very, very low, then you're going to have to reject that null hypothesis. If it's bigger, then you can accept the null hypothesis and use a random effects model. So hopefully that gives you an overview of how to do panel data and cross-sectional data, and then I'll put together a video of time series data next. All right, thanks everybody.